The first notation is called an orbital diagram, right? And what we're going to do is each orbital is a line. Here, orbitals are drawn as boxes. You'll usually see this on web diagrams. But normally, if you just want to use lines and label them like 1s, 2s, if you want to draw lines and label them like this is usually what we're going to wind up doing. So it saves you the time of having to draw the boxes, right? So we draw each orbital out as a line, and then we put each electron in as an arrow following the 3 rules until we've run out of electrons to put in, right? So oxygen has 8 electrons. I put number 1, then number 2, because only one orbital in this sublevel. Then I fill up my second sunny room. This is number 3 and 4. Now I fill up my second P. So number 5 goes here. Following Hund's rule, 6 goes into the next orbital, then 7 into the last orbital. And now I come back and I put number 8 in here. And once I've drawn my 8 arrows, which is the number I'm allowed for oxygen, right? Because oxygen has an atomic number of 8, which means 8 protons and 8 electrons. So once I've drawn my 8, I'm done. I stop drawing arrows, okay? So that's an orbital diagram. The other notation is called electron configuration. We write each sublevel out and the number of electrons in that sublevel as an exponent. So here in this 1s orbital, or 1s sublevel, I have 2 electrons, 2 arrows. So I say 1s, 2. I have 2 arrows in the 2s, so 2s, 2. Now in my 2p sublevel, I have 1, 2, 3, 4 arrows, so I say 2p, 4. And I would keep going in order until I get to the end of my electrons. Right, so this is writing electron configurations and orbital diagrams. So what I want you guys to do is I want you guys to try a couple of these. Silicon, calcium, figure out how many electrons they have, follow the 3 rules, give both the orbital diagram and the electron configuration, pause the video to do this, and then once you think you have an answer, pick the video back up and I'm going to go over these. Okay, so if we start with silicon, silicon is atomic number 14, so that's 14 electrons. I'm going to start off with my first sublevel. My first sublevel is the 1s. I'm going to put in arrow number 1 and arrow number 2. Now, one thing you'll notice me doing is instead of writing full arrows, I usually write these little fishhook type arrows. It's what I was taught to do. If you want to use full arrows, that's perfectly fine. All right, so that's 2 of 14. After 1s, the next sublevel that fills in is 2s. 2s has 1 orbital, so I write one line, label it 2s. This is electron number 3, electron number 4. After 2s comes 2p. P sublevels have 3 orbitals, right? So I'm going to draw 1, 2, 3 lines. I'm going to label these as 2p. Electron number 5 goes here. Number 6 goes into the next orbital because of Hund's rule. Number 7 into the last orbital. Now that everybody has 1, I come back and pair them up. So this would be 8, 9, 10. 2p is filled. I move on to my next sublevel. The next sublevel is the 3s. S sublevels only have 1 orbital, so I draw 1 line. Electron number 11 and 12. That one's filled. Now I move on from 3s, and that next one after that is 3p. So 1, 2, 3. Label them as 3p. So I have 12 electrons so far. This is 13. This is 14. I can only draw 14 electrons in, so that means that I'm done. This is my final orbital diagram for silicon. All right, once I hit the number of electrons, I just stop. And then do the electron configuration. In the 1s sublevel, I have 2 electrons because 2 arrows. In the 2s, I have 2 electrons. In the 2p, I have 6 arrows, so 6 electrons. Then in the 3s, I have 2 electrons. And in the 3p sublevel, I also have 2 electrons. So 1s2, 2s2, 2p6, 3s2, 3p2 is the electron configuration for silicon. And for calcium, I'm just going to do this one pretty quickly. Calcium has 20 electrons. So if I draw this out, 1s, so 1 and 2, 2s, 3 and 4, 2p, 5, 6, 7, 8, 9, 10. After that's 3s, 11, 12. Then I have 3p, 13, 14, 15. Come back for Hund's rule, 16, 17, 18. After 3p, the next one from your diagram that fills in is 4s. 3d gets skipped over a little bit because d's and f's work a little bit weird, right? So 4s is the next one according to our filling order. This would be 19 and 20. I've drawn 20 arrows. I'm done. Now I do my electron configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and that's it for calcium. All right, so this is drawing electron configurations. We're going to do a lot more examples of these in class, and once you actually get used to doing these, you'll easily find out that this is one of the easiest things to do, and you'll become fairly good at it. And a little bit later on, I'll actually show you a bunch of different shorter ways of doing this. All right, so that is the end of this video, and I will see you guys next time.